Hello and welcome to section 5.2. In this section we're going to look at what are called sum and difference formulas, and I've written them over here on the board. Sine of a plus b, I'll use the top sign here to go with the top sign over here. So the sine of the sum of a and b, that is a plus b, is sine a cosine b plus cosine a sine b. Cosine of a plus b, cosine a cosine b minus sine a sine b. So when I use this sign plus here, I use this minus sign right here. Now, in order to see where these formulas come from, you're going to have to go to the book. There's a nice derivation of some of them in there, and you can see what the progression is. But what you really need to know for this is you have to memorize the formula for the sine of a plus b, a minus b, and the cosine of a plus b and a minus b. Now, the way I do it is like this. Sine of a plus b is sine of the first, cosine of the second, plus cosine of the first, sine of the second. So when it comes to the sine formula, it's sine, cosine, cosine, sine. When it's the cosine formula, it's cosine, cosine, sine, sine. So cosine of the first, cosine of the second, minus or plus, depending on what this sign is, sine of the first, sine of the second. Now, as an example of how we would use this, if we wanted to find the exact value, say, of the cosine of 105 degrees, we know 105 degrees is 45 degrees plus 60 degrees. Well, I know sine and cosine, exact values for sine and cosine of 45 and sine and cosine of 60. So I can take my cosine formula and write the cosine of 45 plus 60 as cosine of the first, cosine of the second, minus sine of the first, sine of the second. That's just applying this formula to this expression right here. Now, cosine 45, square root 2 over 2, cosine 60, 1/2, minus sine 45, square root 2 over 2, sine 60, square root 3 over 2. So the exact value of the cosine of 105 degrees turns out to be square root 2 minus square root 6. That's this product minus this product, all divided by 4. So one application of these sum and difference formulas is for finding exact values for more trigonometric functions than we had in our previous list of 30, 45, and 60. Let's go to the board now and look at a couple other problems. First problem here is an identity. I want to prove that the sine of 3 pi over 2 minus x is equal to cosine x. So I'm going to apply my formula for the sine of a minus b. So it will be equal to sine of the first, 3 pi over 2, cosine of the second, cosine x, minus, because when it's the sine formula, the algebraic sign matches. So sine of the first, cosine of the second, minus cosine of the first, 3 pi over 2, sine of the second, x. So sine, cosine, cosine, sine for sine of a minus b. Now, the sine of 3 pi over 2, that's going to be equal to negative 1 times cosine x, minus cosine of 3 pi over 2 is 0. I've got those exact values memorized. 0 times sine x is going to be 0, so I get minus 1 times cosine x is minus cosine x. So minus 0, which is still minus cosine x. So I've succeeded in turning the left side of this into the right side using this sum formula. It simplifies down to minus cosine x. Now let's go to the next problem, which is also an application of the formula for the sine or cosine of a sum or difference. Let's take a look. Problem number 2, we want to simplify cosine 15, cosine 75 minus sine 15, sine 75. Now this looks like cosine A, cosine B, minus sine A, sine B. Now I know that this is the expanded form of the double angle formula cosine of A, not minus, but plus B. So if A is 15 and B is 75, then this is going to be cosine of 15 degrees plus 75 degrees, which is the cosine of 90 degrees. Now I can simplify cosine 90. Remember, if I want, I can just draw a quick sketch of the cosine curve. Starts at 1, goes to 0, down to negative 1, back up to 0, and then up to 1. This is 2 pi. This is pi over 2. And this is pi over 4. I'm sorry, this is pi. This is pi over 2, and this is 3 pi over 2. So cosine of 90 degrees, that's going to be right here, is 0. So cosine of 90 degrees is 0. I can use a calculator to get that, or I can just simply sketch the cosine curve real quick and look at 90 degrees and remember that, and see that cosine of 90 degrees is 0. So here I have an expanded expression. I rewrite it down as the cosine of a plus b, 15 plus 75 is 90, cosine 90 is 0. Let's look at our next problem, problem number 3, a graphing problem. We want to graph from x equals 0 to x equal 2 pi, y equals sine 5x cosine 3x minus cosine 5x sine 5x. Whoops. So I'm going to change this. I copied the problem wrong to sine 3x. Okay, this looks to me like sine A cosine B minus cosine A sine B. Now I know that this expression is the expanded form of the sine of A minus B. So I'm going to write y as the sine of 5x minus 3x. So y is equal to the sine of 2x. So I want to graph the equation y equals sine 2x, and I see that my amplitude is going to be 1. My period will be 2 pi divided by the coefficient of x, which is 2. So I get a period of pi. Now the instructions say to graph this from 0 to 2 pi, so I'm going to put 2 pi in here on the curve. My amplitude is 1, so I just put in 1 here, negative 1 down here. Here's 2 pi, halfway is going to be pi, halfway here is pi over 2, and then this point is 3 pi over 2. So I want to graph on this coordinate system between x equals 0 and x equals 2 pi, y equals sine 2x. So I have an amplitude of 1, a period of 2 pi divided by 2, which is pi, so this will go through one complete cycle between 0 and pi, and it's a sine curve. So I'm going to start at 0, go up to 1, back down to 0, down to negative 1, back up to 0. There's one complete cycle of the sine curve in a period of pi units. Now, because the instructions say to go to 2 pi, I'm just going to continue this, go back to 1, back down to 0, down to negative 1, and back up to 0. So there's the graph of y equals sine 5x cosine 3x minus cosine 5x sine 3x between x equals 0 and x equals 2 pi. Let's go to our next problem, which is also a graphing problem. Problem number 4, graph one complete cycle of y equals sine x cosine 4x, cosine pi over 4 plus cosine x sine pi over 4. Again, this looks like sine A cosine B plus cosine A sine B. And I know that this is the expanded form of sine of A plus B. So my equation then must be y equals the sine of x plus pi over, 4. So I have the equation y equals sine of x plus pi over 4. Now this is going to be a sine curve. It's going to have an amplitude of 1, a period of 2 pi, and it's going to have a phase shift of negative pi over 4. So I want an amplitude of 1. It's going to go up to 1, down to negative 1. It's going to have a phase shift of negative pi over 4. So I'm going to put negative pi over 4 in right here. That's where the curve will start at. Now it's going to end at the phase shift, which is negative pi over 4, plus one complete cycle, or the period, which is 2 pi. So that's negative pi over 4 plus 8 pi over 4, which is 7 pi over 4. So the curve's going to end at 7 pi over 4. Let's just get this sort of proportional. There's 1 pi over 4, so 1, 2, 3, 4, 5, 6, 7. So I'll put 7 pi over 4. Right here is the ending point. The point halfway between the starting point and the ending point, I'll just put it in right here. It's going to be negative pi over 4 plus 7 pi over 4, which is 6 pi over 4, all divided by 2, so that's 3 pi over 4. Halfway right here will be pi over 4, and right here, 5 pi over 4. So now I'm going to graph a sine curve that starts at negative pi over 4, ends over here at 7 pi over 4, and it should look like this. It starts at 0, goes up to 1, back down to 0, down to negative 1, back up to 0. And it's a sine curve, so the graph will look like this. Okay, so there's the graph of the original equation, y equals sine x cosine pi over 4 plus cosine x sine pi over 4. Now let's go to the next problem, which involves double angle, or the sum formula for sine, cosine, and tangent. Let's take a look at it. So if sine A is 3/5 and A is in quadrant 2, and sine B, another angle, is negative 5/13 with B in quadrant 3, let's find the sine of A plus B, cosine of A plus B, and tangent of A plus B. Well, I know all of these formulas simply depend on the sine of A, cosine of A, sine of B, and cosine of B. So I'm going to find sine and cosine of A and B. Here I have the two sines. Let's find the cosines also to begin with. So I have this. If sine A is 3/5, cosine A, I know from my experience with sines and cosines of angles that come out 3/5 and 4/5 that the cosine of A is going to be 4/5. Now A terminates in quadrant 2. In quadrant 2 the sine is positive but the cosine is negative. So I have to give that a negative sign. Now cosine of B, if sine of B is negative 5/13, then the cosine of B is going to be 12/13, and B terminates in quadrant 3, so the sine is negative and the cosine is also negative. So now to find the sine of A plus B, that will be sine A cosine B plus cosine A sine B. So now simply substitute. The sine of A is 3/5. Cosine of B is negative 12/13. Plus, that's that plus sign, cosine of A, negative 4/5, times the sine of B, which is negative 5/13. Now the rest is just arithmetic. I'm going to simplify. 3 times 12 is 36, so I have negative 36. 5 times 13 is 65, plus negative 4 times negative 5 is positive 20 over 5 times 13, which is also 65. So this ends up negative 16 over 65. Negative 36 plus 20 is going to be negative 16, so I have negative 16 over 65. Now to find the cosine, I want the cosine of A plus B. I'll use my expansion formula, cosine A, cosine B, minus sine A, sine B. So you see I've memorized these formulas for sine A plus B and cosine A plus B. I know what the expansions look like. I don't have to look it up. Hopefully after you've worked the problems in this problem set, you'll have them memorized too. Now the rest is just substitution. Cosine of A comes out to be negative 4/5 times cosine of B, negative 12/13, minus sine of A, 3/5, and sine of B, which is negative 5/13. Now if I multiply this out, I'm going to end up with positive 48 over 65, minus 3 times negative 5 is negative 15, so I have minus a negative 15, which is plus 15, all divided by 65. And so I end up with, let's see, 63 over 65, a positive 63 over 65, and that is what the cosine of A plus B is. So I have sine A plus B, cosine A plus B, and now I want tangent A plus B. Tangent A plus B will just be sine A plus B over cosine A plus B. So if I simply take negative 16 over 65, divide by 63 over 65, I'll get the tangent, which will be negative 16 over 63. So I won't show that work. But in any case, here is a little more complicated problem. Two angles, we're given a sine of one and a sine of the other one. We have to begin the process of finding the sine of A plus B and cosine of A plus B by finding the cosine of A and the cosine of B. So I write those down first, and the rest is just substitution. Okay, our last problem, we're going to do a little proof that involves sum and difference formulas. Let's take a look at it. I want to prove that sine A plus B plus sine A minus B is 2 sine A cosine B. So I'm going to take this side and expand using my sum and difference formulas, then simplify. Hopefully it'll come out to be 2 sine A cosine B. So first of all, sine of A plus B on the left side here is going to be sine A cosine B plus cosine A sine B. Now, sine of A minus B, that's going to be sine A cosine B minus cosine A sine B. So I expand the left side using my sum, the formula for the sine of a sum, and the formula for the sine of a difference. Now, sine A cosine B minus, let's see, what do I have? Cosine A sine B. That's not the one I want. Let's see. Sine A cosine B. I have this sine A cosine B right here. So I'm going to take this and add them together. That's 2 sine A cosine B. Second, I have cosine A sine B, and here I have negative cosine A sine B. That's 0. So it'll be 2 sine A cosine B plus 0, which is 2 sine A cosine B. So you see I've succeeded in changing the left side into the right side, 2 sine A cosine B. So there's a look at some of the problems that we can work using the formulas for sine A plus B and cosine A plus B, and even tangent A plus B, the formulas for sine and cosine of the sum of two angles and the difference of two angles. Most of the problems in this problem set are just to get you used to using those formulas, help you get them memorized, and see the kind of problems that you can work using them. Before we leave this section, I want to take a minute and use the graphing calculator to give a little more evidence that these expressions for the sine of A plus B and cosine of A plus B are in fact the correct expressions. If I look at the expression sine x plus 2, what I want to see first of all is that this is not the same as the expression sine x plus 2. Sine x plus 2 in trigonometry, from what we know from this section, has to be sine x cosine 2 plus cosine x sine 2. But the most common mistake students make when working with an expression like this is just to simply write it again like this. So what I want to do is take the graphing calculator, set this expression equal to the y1 variable, this expression equal to the y2 variable, graph them, and see if we can compare the graphs of these two expressions, and that'll give us some insight into it. So let's take a look at the graphing calculator and see. Let's take a look and see how the graphing calculator will do this. Let's see. I better turn it on. Okay. Now, I'll show you my y variables here, and you can see I've got my y1 variable set up to be sine of the quantity x plus 2. y2 is the sine of x plus 2. Now, let's check the window out that I'm going to graph in. I'm going to have x minimum, or x go from 0 to, I've got down here 2 pi, go in increments of pi over 2. Y is going to go from negative 3 to positive 3 in increments of 1. So let's take a look at the graph. There's my first function, y equals sine of the quantity x plus 2. Here's my second function, y equals sine x plus 2. And that looks like you would think it was. This looks like a sine curve moved up 2. As you can see, these two curves don't intersect at all, meaning that the two expressions that we graphed can't possibly be equal. So let's go back to our y variables. Our first expression is sine of the quantity x plus 2. The second expression is the sine of x plus 2. So what the graphing calculator tells us is that these two expressions right here aren't equal because we've graphed each one of them, and we see that the graphs don't even intersect at all. So that's the first indication that the sine of the quantity x plus 2 can't be equal to the sine of x plus 2. In fact, we know from this section what it is equal to is the sine of x cosine of 2 plus cosine of x sine of 2. Now, if we were to graph that function, we would see that it would coincide with this graph and wouldn't match this graph at all. I'll leave that up to you. So another way in which we can use these graphing calculators to convince ourselves that some of the things we're doing in trigonometry are in fact the correct things to be doing.